Okay, here's the problem. We've got this function, y equals e to the minus x squared, which that's this red curve right here, bounded by x equals 0, x equals 1, y equals 0. That region we're going to revolve around the y-axis, which is the dashed green line, and we're going to find the volume that's generated by doing that. Okay, so using the cylindrical shell method, these blue lines are modeling a typical cross-section of the cylindrical shell. And the height of that shell is e to the minus x squared. Take away the y coordinate at the bottom, which is 0. So this is just the height of every shell for every x between 0 and 1. And then when you use the cylindrical shell method, you have to multiply by the average radius, which is the distance from the axis of revolution to the center of the shell. And for each x, that's just x. So here's the setup. 2 pi, definite integral from 0 to 1, average radius times the height of the shell. And to evaluate that definite integral, you probably want to use u substitution. So let u equal minus x squared. So du is minus 2x dx. So if you picture putting a minus 2 right here, you got to put a minus 1/2 out front and then do the substitution. And you can make note of the fact that when x is 0, u is 0, but when x is 1, u is minus 1. So what does it look like after you do the u substitution? Well, here's an answer, a decimal approximation, using f of x for e to the minus x squared. Here's what you get after the u substitution. And if you want to move the negative 1/2 out front, which I did earlier, you can write it that way. And then if you want to interchange the limits of integration, so the lower number is at the bottom, you get this. And then if you find the antiderivative of e to the u, it's still e to the u, put in a 0, minus, put in a negative 1. And I guess that's a possible way to write the final answer right there. Okay, there you go. Hope that helped. If you have any questions, post a comment.